As part of layer 2 devices, or L2 devices, we have something called a switch. Switches have a primary purpose of connecting devices in your network together, and they're different from routers, and most households don't have standalone switches since they'll typically use Wi-Fi from routers to connect to the internet. But since switches are L2 devices, they use the MAC address to send and receive packets. There are a number of different switches in many different sizes, and you can usually visually identify switches by the number of ports that they have. Routers, which we'll discuss in the next chapter, typically have fewer ports, maybe somewhere between 2 to 4, while switches, on the other hand, usually have at least 4 to 8 ports, all the way to 48 ports. So in simple terms, it means that switches are used in wired networks to connect devices with Ethernet cables, which allows those connected devices to talk to one another without having to rely on Wi-Fi. And this can help with stability, reliability, and performance of that communication. So maybe you have one of these routers in your house. The blue port is typically labeled Internet, and the yellow ports are a small switch module directly integrated in the router. And as you can see, the quote-unquote router part has one port, that blue port, and then the quote-unquote switch part has more ports, the yellow ports. But internally, the device interconnects both parts, and then the antennas provide Wi-Fi, which is also internally connected by the device. But since this device is for home use, it's not designed to connect a lot of different devices. In this case, you can connect 4 devices using an Ethernet cable and then additional devices via Wi-Fi. And if you connect too many devices, especially using Wi-Fi, service will tend to degrade. So in corporate environments, it is more common to see switches with more ports, and they look a little bit like this. The difference between these mostly has to do with capacity. Though some switches will offer other features as well, like the ability to prioritize traffic or control who can access what, monitor usage, etc. So when buying a switch, consider the size of your network and the expected growth. So what kinds of devices can connect to switches? Well, there are many different kinds, like your computer, your IP cameras, which are simply cameras that connect to your network, even wireless access points, which are used to extend the range or capacity of Wi-Fi. You've got TVs, printers, storage devices, etc. Then, one of the switch's ports will connect to a router, which then connects to the internet. Now, we will later discuss routers and how they work in the next chapter, so for now, let's go ahead and focus on the switch. Now, like I said, wireless access points connect directly to a switch, but these access points will also be working as a switch, since they do have their own MAC address, and they use both source and destination MAC addresses. But of course, a difference between them and a switch is that wireless access points let devices connect via wireless instead of Ethernet. There are also switches that use a technology called Power over Ethernet, or PoE, and this technology allows the switch to provide power to some devices using the same Ethernet cable that is used to send data, meaning that they don't need any additional power supply to power on those devices. Switches that support PoE technology usually have a visual representation to highlight the available ports that can be used for this purpose. A switch can even have all or just part of its ports using PoE, so when using them, you need to read the switch's specification sheet to be sure of which ports you can use and how many devices you can connect. Some examples of using PoE would be for things like phones or cameras or even wireless access points, which may not need a lot of power to function, and so we can plug them in directly to those ports instead of needing a separate power supply. So now that we understand a little bit more what switches are, what their primary function is, and how they fit into a network, let's go ahead and complete this lesson, and in the next lesson, we'll explain in greater detail how switches work in combination with MAC addresses.